So the next few videos are going to look at chapters 16 and 17, focusing on the processes of evolution and natural selection. Okay? So things that we'll look at in reference to evolution is how does it happen? What types of changes can evolution cause in a population? And then what is the evidence that exists for us to think that this is the cause of all the radiation of species throughout the whole planet? And then we're going to look at the process of natural selection specifically that leads to evolution. So, some of the things that were believed a couple of thousand years ago, Plato, Aristotle, they had a heliocentric view where the Earth is the center of the universe, the Earth isn't very old, and life is how it always has been. There was an ideal form that was made, and that's what exists. And then any variation that exists are just simply imperfections. And then obviously, man is in the top of this ladder. Man is the peak of all living things. And so they believe that man's just sits at the throne here. And this view stood for a couple thousand years. And so in comes Charles Darwin, who most people will associate with evolution. And now, this theory of evolution wasn't really Charles Darwin's. He wasn't the first one to come up with this. It had been around for quite a while, but the studies that he did really got a lot more people to start believing this idea of evolution because he put forward studies and some of the science of what he observed to make it more believable rather than just being this idea. Okay. Early European naturalists explored Africa, Asia, America, most places around the world, and saw there was all sorts of diversity. Okay. Loads of variations between organisms, but they did see that there were a lot of similarities that existed in similar environments around the world. And then also similarities even in quite different environments. And so this idea started to come about that maybe these very similar species came from a common ancestor and they just had slight changes because they lived in different places. We got fossil evidence, right? We started to dig up these bones of animals that no longer existed. And what they typically found was the same fossils always ended up in the same rock layers. Okay. And so things that they questioned, did different organisms live at different times, right? Because we had that Plato and Aristotle view. All of the organisms that have existed still exist and so on. And is the Earth as young as we think it is? Could it be older? So here are some similarities that we see between placentals and then marsupials, these on the right side mostly being organisms native to Australia or New Zealand. And so we see a lot of similarities between these organisms, even though they're quite a bit different from one another. But they live in very similar types of environments. And so we see some strong similarities. Okay, and then looking at fossils and the fossil record and these layers, we find all sorts of information in types of fossils that exist. Georges Cuvier came up with this idea of catastrophism. He believed that Earth started with one set of species, and so everything that has ever existed was made, and then huge events happen, these catastrophic events, producing these rock layers that we find fossils in, killed off a lot of stuff, and those that made it through these catastrophic events are the species that we still see today. The issue with this idea is we don't find modern species embedded within these ancient fossils, right? If we had these catastrophic events, it wouldn't just pick out these certain organisms. It would have killed other things too. But we don't see any of these modern things in these fossil layers. So odds are they weren't part of that original set of species. Okay, we come to Comte Georges de Buffon. He believed that there was an original creation providing a few founding species. Okay, and then modern species evolved from these original species. Okay, so here in the mid 1700s, we have this naturalist coming up with this first idea of evolution. And so he came up with this idea, but the issue was he had no mechanism of change. So he didn't have an explanation as to how this process of evolution occurred. And then also, nobody believed Earth was old enough for this change in species to have occurred, for evolution to have happened. Okay. Geologists James Hutton and Charles Lyell came up with the idea of uniformitarianism. So they look geologically, these processes on Earth that occur have always happened, they're still happening, and they will always continue to happen. So we don't get these big catastrophes that we saw in catastrophism. We get this uniformitarianism where over long periods of time, we get these rock layers to build up, and then fossilization can happen when we get organisms buried in this sediment and so on. So the change is gradual, but it's constant change. And so this says that Earth must be older than these other estimates, which at this time, estimates came from some preacher looked at the Old Testament of the Bible, added up the ages of all these people, and got about 6,000 years. So for most of the Western world, a lot of people believe this to be true because the Christian religion had gained so much influence around this time. Later on, a scientist by the name of Lord Kelvin came up with this idea that it was a couple million years old, but it couldn't possibly be any older than that based on the heat from the core of the center of the Earth. Now, that was before we knew about radiation. And so current estimates by aging of rock crystals and things through radioactive decay, we get about 4.5 billion years old for the age of the Earth. So it's certainly old enough for this idea of uniformitarianism to be true, and definitely old enough for this idea of evolution to have produced the species that we see today. Before Darwin, we had certain mechanisms of evolution. And so we've got Lamarck here, where we've got Lamarckian evolution. And he looked at the fossil record. So we had these old simple fossils to more complex fossils in the higher up rock layers. So the theory that we get from Lamarck is that evolution, this process, is toward perfection. And eventually we'll end up with perfect organisms, whatever it happens to be. And he also believed that organisms evolved through the inheritance of acquired characteristics during organisms' lifetime. So basically, we look at the picture of giraffes here. As a giraffe grows and its neck gets longer during its lifetime, it then passes on a longer neck to its offspring. Okay? This is kind of a silly idea because, as we've learned in previous chapters, inheritance is based on genes, specifically in the genes of our gametes, our sex cells. That's what gets passed on to our offspring. So growing a longer neck or something happening during our lifetime isn't going to change our offspring. And so we see that this Lamarckian evolution isn't true. And experiments that work off Lamarck's idea, here in one example, you cut off the tails of mice for each generation for many generations, but they always grow their tails back. Their offspring are never without a tail. Okay, and that would be a characteristic that's acquired through its lifetime, but it isn't being passed on. Okay, so in the next video, we will start looking at Darwinian evolution.